What is going on, ladies and gentlemen? In today's video, I'm going to be going over a roadmap on how to become a back-end software engineer. Whether you're just starting out or you're looking to transition into a more exciting field, I have you covered. Let's get started. So what is a back-end software engineer? Well, a back-end software engineer works on server-side applications, handling data storage, retrieval, and ensuring that everything runs smoothly behind the scenes. And usually the first step with becoming a backend engineer is selecting a backend language. And there's really a lot to choose from, but here's a list on some of the popular ones. So there's Python, JavaScript, Ruby, Java, Go, Rust, C Sharp. And the more popular ones are Python for like stuff like Flask and Django, JavaScript for Node, Java for Spring Boot. I have a couple videos on that, but really choosing a language will put you in the right direction on becoming a backend engineer. So if you already know a couple of these languages or just one, you're really on your way to becoming a backend engineer. The second step is understanding the internet. So understanding on how everything works, learning what HTTP is, learning what a domain is and what a DNS server is and how it's utilized to grab the proper site based on what you inputted in the URL, what is hosting, how to handle a browser request, how is a request formatted, how to send response back, and what is a HTTP status. So I know sometimes you guys may visit a website and there's an issue and you may see a 500 error or a 404 error, or sometimes where everything is working properly, you may see a 200 or 201. What exactly do those codes mean is important to understand. So this is where you should get an understanding of that before moving on. You should understand how to utilize Git. Git is a version control system used for tracking changes in computer files. So in our case, computer files will be code files. So whether you're coding in Java, Python, JavaScript, whatever, you want to keep track of the changes that you're making, and you want to work in tandem with a repository. So when you're making those changes, you're pushing those code changes to a repository, so it's storing your code. Usually a popular one is GitHub, there's GitLab, there's Bitbucket, but you're pushing your code to those repositories, and as you're making changes, you're pushing it to the repository so you could see those changes and you could have different versions of those changes so you know exactly what was added or what was deleted. It's just a good way to keep track of your source code. Then the next thing is to learn a backend framework. So based on the language that you chose initially will kind of define the path that you take. So say for instance you were to learn Java, you may want to go the Spring Boot route, or if you learned JavaScript, you may want to learn Node.js and Express. And if you learn Python, you may want to go to Django and Flask route. So depending on the language that you chose, there's different frameworks for that language. Or if you want to just hop on and learn a new language because you found a framework that fits what you like and the flow that you like, then you can learn another language and pick up that framework. You're not restricted, but say for instance you already have some knowledge on the language on prior projects or prior experience, you can utilize that with a framework that's already created for the language that you already know. So choose a framework that you want to work with and go from there. The next thing you should learn is how data is stored with databases. You should learn SQL, which stands for Structured Query Language, and then with that knowledge you can use it in conjunction with a popular relational SQL database such as Postgres, Microsoft SQL Server, and MySQL, Oracle. There's many relational SQL databases, but after you get an understanding of the SQL language, you can use it in conjunction with a database management server. And the popular one right now is Postgres. I use it all the time, but you can do research on what you need and if it fits your use case. Then there's also NoSQL databases, right? And what you should learn is which one is best to use in different scenarios. So when is it good to use a relational database and when is it useful to use a NoSQL database? Learning the difference between the two is important, and I get it a lot in interview questions. So knowing the difference and when to use it is great. And some popular NoSQL databases is MongoDB, Cassandra, Firebase, and Redis. Redis is often used for caching, right? It's the key and value, and that's usually what a NoSQL database is. It's all about key and value. You use a key to store a value, right? And if you know about Firebase, Firebase is a real-time database. So you place a key, and then you have a value, and you can grab it and update it in real time. So learn the difference, learn how data is stored, and then move on to learning database conventions. Learn what ACID is, and ACID is just an acronym for atomicity, consistency, isolation, and durability. So learn what that is, learn what transaction is, learn what normalization is, learn about the N+1 problem, learn how to handle failures, learn what happens if a database goes down, what to do if someone is reading data while data is being written to the same location, how to back up data. So these are things that you should learn how to do when it comes to dealing with databases, because in a case like Google or any big website that's dealing with a lot of data, when you're doing interviews with these companies, they want to know that they have an engineer that understands on how to deal with a database that's always being manipulated, right? Always being written to, always being read, always being updated. They need to understand that you can provide some knowledge or add on to their team, and they don't need to teach you everything, right? You should have a base knowledge of database conventions. So it's always good to write clean code. It's always good to utilize linting and code formatters to make sure that your code is structured and it's in the proper format, and that if you're working on a team, that everybody is structuring the code the same. So you should learn about different packages to make sure that your code is clean and formatted properly. And you can't go wrong with testing your code to avoid problems. So you should learn what a unit test is. You should learn what integration tests are. You should learn what structural tests are, functional and integration testing, schema testing, and validation testing, which is just making sure that the data is hitting your backend and is properly structured. You should know what non-functional testing is, so that involves load testing, risk testing, and databases stress testing. So there's different testing you can do for backend engineering, but I'm not trying to overload you on this. Just start with one and just continue to grow on it. Usually when you're working on a team, anything that you write while on a team, they expect you to write unit tests for it. So it's tests for small chunks of your code. So if, say for instance, you were to write a function, you should have a test for that. So understand what unit testing is and all different types of testing that can be done for backend engineering. For example, for stress testing and for Java-based backends, there's a program called JMeter, which is often used to do stress testing, which sends a series amount of requests to a backend to see how the backend handles that elevated level of requests, right? Will it crash? If it does crash, how does it handle it crashing? So sometimes it may send 100 requests simultaneously. Can it handle those requests? Does it spread out the requests to different backends? These are things that are often tested, and having understanding on why and how it is done is important. Now, with all this data that's moving around and being stored in databases, we need to have understanding of security. You got to protect yourself at all costs. So learn about authorization and authentication with things such as JWT tokens. Learn about hashing algorithms and keeping user data protected. Learn how to store personal data and backing information in case of errors. Have an understanding of API security best practices, such as using cookies or OAuth or basic auth versus token auth. Learn about security rules and OAuth risk. I took a whole class in college about different security rules and how you should protect your application. And even in a 16-week course, it really wasn't even enough. There's so many ways that people try to take advantage of your application and try to get information that you are trying to protect. Right? There's people that wake up in the morning looking to take advantage of your software. So try your best to secure it. Then it's learning about containerization with Docker, right? So Docker, just to keep it simple, packages your application into units called containers. And to keep it short, it allows you to run consistent code on different machines. So understanding how to use Docker for development and deployments, especially when you want to work as a team and make sure that it runs on everyone's devices the same, it's important to understand containerization, especially with Docker. And if you want some bonus points, you could learn about Kubernetes, especially when you're trying to scale your application and making sure that when your application does crash, it's able to spin up another container, no problem. You don't have to do it manually. It can be done automatically with using a program called Kubernetes. But it's not a must, but it will just be bonus points. But having an understanding of Docker and what containerization is, what an image is very important. And then learning architectural patterns. So by default, we usually build monolithic applications, meaning it's one big system with all our code. But as we grow and as we expand as an engineer, it's good to learn different patterns. So, like I said, monolithic is good to understand, but learning what microservices and serverless is and why it's important to use those different approaches for different use cases is important. So these are just a few that are very, very popular to understand, but there are definitely more. But have an understanding of each one is important, and maybe in a meeting when you're on a team and they're talking about what patterns to use for a new project, you can have some input on that because you know what the pattern is. Then there's scalability. So the goal is that people love your application so much that traffic increases. So now you have to learn how to deal with that influx or that increase of users using your application. So learning about scalability, you need to understand how to design scalable architectures to handle increased traffic and data. So how to take things like Kubernetes, and when it sees that 1,000 is going from 1,000 users to 1,000,000 users, how to spin up new instances of your backend from just one backend to 5 backends so that it can handle that increase of users using your backend. So understanding how to do that, learning about how to monitor those requests that are being sent to your application or to your services, and keeping track of how the data is coming into your system and leaving your system. Learning about telemetry, and which is often used to monitor and control the state of your application's health and performance. So learning all this is important, especially with a growing application, or if you choose to work for a company like Google or Amazon, who deals with millions and millions and millions of users. Learning about how to make a scalable system is important. Now, it isn't a must, but usually backend, and during my time of being a backend engineer, it's important to understand what a CICD pipeline is and how your backend is going from the plan phase to actually being utilized by users in real life. So going from plan to delivery is pretty important. So having an understanding of continuous integration and delivery, or CICD for short, is important. So CICD is a process used to frequently deliver applications to consumers using automation, and the goal is to integrate features and continually deliver those features with no problem. So your goal should be just writing code, and once you merge your code into the main branch or your production branch, it should automatically build your application and push it to deployment, right? You should have an understanding of how that's being done, what programs are being utilized to get that done, such as Jenkins or Travis CI, or any type of code pipelines in cloud providers like AWS or Azure. Understanding why and how it's being done is very important. So just get an understanding, even for a basic level, of CI/CD pipelines and how it's being done for your service, or even if you can do it personally for a personal project, try to get an understanding of how that's being done, and that would definitely elevate your knowledge compared to other people. And speaking of cloud providers, have an understanding of cloud services like AWS, Azure, and Google, because those are the three big boys when it comes to the cloud. So, to be honest, sometimes companies expect the backend engineer to be competent in DevOps work. So, like I said, exploring AWS, Azure, and Google Cloud will usually put you above a lot of people, especially if you're just getting started in the industry. And if you already know how to utilize the cloud, it'll definitely elevate you compared to your peers. So getting hands-on experience deploying work, like I said, even if it's personally, will definitely elevate your game. Understanding message brokers. I already have a Kafka video, so that's an example of one message broker. But once you start expanding, it's important to understand how message brokers work. Kafka, RabbitMQ are the popular ones. So brokers are used to communicate between services. And like I said, I already have a Kafka video and how to utilize it with Spring Boot, and I even have a separate Kafka video on what it entails and what it does. But essentially, it will allow you to communicate between services, and Kafka is often used to communicate between two backends. So you may have a backend specifically for authentication, then you have another backend for actually storing information, such as maybe it's a banking company that stores funds based on a user. So you may have a application that you'll log in the user, provide a token, and then you may have another application that based on the user, right, that logged in and sent a message. You send a message using Kafka or RabbitMQ, and it will store that information into a database. So, and that allows for the decreased load on applications, because now instead of having to wait for something to be done, right? So you send a request to a backend and you have to wait for it to send a response back. You can now just send a request, it sends a message to the broker, and then now it can send a response back to the user saying that we received the message, and we'll handle it on the back end. The message broker will do it whenever that pipe is done processing the message, but we're not going to have you wait for that message to be done. It's just going to handle it on the back end, right? So you can use message brokers in that sense, and it will decrease the load on your application. So having understanding of message brokers and when to utilize it is very important. So I recommend you learning the popular ones like Kafka and RabbitMQ. And then there's learning development patterns. So you have a gist of the language that you like, the framework that you like, how to test that code, and different types of patterns. But there's development patterns on how your code is being structured from the beginning. So for example, there's test-driven development, which focuses on writing test cases before actually coding, right? So the functionality is worked around the test. So some like it, some hate it, but learning these principles can help figure out the approach that fits you and your companies. So like I said, there's test-driven development, which is centered around tests before actually coding. And then there's domain-driven design, there's event sourcing, there's documentation-driven design. So there's different types of patterns when it comes to development that can be utilized for creating a development experience. So understanding what these are, and like I said, maybe you can bring this to companies that aren't using it yet. So maybe if you're getting hired and maybe you're in a lead position and you're trying to find a way that everybody can be on the same page, you can take one of these development patterns and utilize them in your company, and that can help everyone be on the same page and create a clean experience. So having understanding of each one and knowing that they're out there can help create a more clean development process. Then there's the last step, which is really just staying up to date and just continue learning and staying in touch, and eventually getting that job if you don't have one, right? Backend development is always evolving. Really, technology is always evolving. So staying up to date with industry trends, new tools, and best practices is important. Build a strong portfolio is crucial. Work on personal projects, contribute to open source projects, showcase your skills on platforms, and store it in your GitHub. Sometimes just applying will not work. Be sure to network and utilize references with people working in companies you already are interested in. References allow for faster access to companies, and most of the time employees are incentivized to provide references. So if you see someone on LinkedIn, they work for Microsoft or any other type of company, they may be incentivized to give you a reference, because if you get hired at the company and they give you a referral, then they get paid for it, or they usually get paid for it because you were hired based on their reference. So sometimes if someone sees that they like you and they see that you're a go-getter, they will give you a reference, and that can be a quicker process of getting an interview than just applying on the website. And try to utilize forums like Reddit, Discord, LinkedIn to be a part of virtual communities, because having your resume in different places and being able to communicate with actual people in these communities can help get you opportunities way faster than just applying on a website and just waiting, right? Actually having real-time communication with these people can help you get that interview faster. So try to do that. Try to be a part of these virtual communities. Try to go in person and virtually to conferences, talk to people. And I know at the time of this video, there's a lot of hiring freezes. People are not hiring as much, but just creating that relationship and creating that network when opportunities do arrive, usually those people are the people that they reach out to first, people that they know, right? People that they know, that they talk to, that they need a job. They'll usually reach out to you because they have that connection with you already. Try to keep in touch with tech news and new software coming out in the community. Continue to increase your skill set. This is a forever learning thing. So just try to keep track on that. Try to find a blog or a website that has news that's continually coming out every day or every week. You maybe try to sign up for a newsletter and keep track of the latest tech. So the journey is over when you stop learning. That's a great quote that I heard. I forgot who I heard it from, but it's true. Like when you stop learning, that's when the journey stops. But if you keep learning, it's going to keep going. So just like I said in the front end roadmap video, and with this video is the same, I hope I didn't scare you. This is not a 1 month journey. It takes a long period of time to master it, and even when you master something, there's always something new that comes out. But just keep going, keep learning. And if you found this video helpful, please give it a thumbs up and subscribe for more tech related content. Don't forget to hit that notification bell so you don't miss any other future videos. Thanks for watching. I'll see you in the next one.